All right, everyone. Going back to what we had this yesterday. So consider this particular problem wherein you're going to estimate the value of y when your input, meaning when your x value is equal to zero point 0.4. Of course, here, for us to do that, we need to solve this um, differential equation for us to get y, a function y equal to in terms of x. So remember how to solve differential equations? Please try to review. So in this case, this differential equation is non-separable. So we're going to write it in this form. Okay? Writing it in this form gives us this one. And so from here, we could already find these particular expressions. Also, the integrating factor can be solved using this notation, by which if we are to substitute p of x, we get this. Thus, your integrating factor would now be equal to this. And recall on solving differential equations, once we have all the needed information, we can now find the y. What function of y in terms of x will this differential equation be equal to when solved? Okay? So please take time to review. So substituting the given expressions, all right? Or we can rewrite this in this particular method or format by which we need to apply integration by parts. All right? Applying integration by parts on this. So I expect you to review this already as I won't show this in this particular presentation. So we now get this one. Okay? And simplifying it results to this. Now, since we know from the problem that y is 0 when x is 0, we can plug in those values in order to find and solve for the c. Because what we have right now is simply a general solution. So we need to have a particular solution wherein we have a value of the c. So putting in the 0 will lead us to get a c equal to 1/4. And putting in 1/4 here, thus we get this one. Combining them all together, therefore, solving this differential equation would lead us to this function of y in terms of x. Now, once we have this, we can now answer the question by means of substituting zero point 0.4 on the x or by means of graphing it. So when we do graph it, it looks like this. At x equal to 0 0.4, your y is more or less greater than 0.1. So that is how we are going to solve it. But looking at it, the process is very long. It's very, very long. Therefore, if you try to read the problem again, you are not asked of the exact value, but you're only asked of the approximate value or an estimate only. Thus, you don't have to give an exact value. Therefore, you don't have to do the process, the long process that we just had. So the question now is, without doing this process, how do we find an approximation or an estimation? That is where Euler's method comes in. But for you to understand Euler's method, I'd like you to go back to this particular curve. And from here, let's try to focus on a point found on the curve. So let's say this is the curve of the differential equation, and we try to pick on a point from that curve. Let's say this point. Now, when we create a tangent line crossing this particular point, we actually can get another point here. Okay, so this point is actually another point found on the tangent line by which this tangent line crosses the curve at this particular point. Since it's tangent, we expect that this line will only cross or will cross this curve only at one point, which is the chosen point. Now, since this point is to the right of this chosen point, let's call it x sub n, y sub n. And the point which is previous to that, before that, is your x sub n minus 1, y sub n minus 1. All right? So from here, since this is a line, we can actually get its... So this is the point on the curve, this is the line tangent to the curve, and of course, this is another point on the line. So we can get its slope, all right, using the 2 points on the line. So using the formula change in y over change in x, wherein this change in x is just simply the height. All right? So if you try to get the change in the vertical height of the second point minus the first point, you just get the height. And sometimes we call it the step up size, or the height. All right. Now looking at it, if you try to recall, this is done using algebra, using 2 points. We could also find the slope using calculus. If you recall, to find the slope, we need to take the derivative, all right? And we need to input the coordinates of this particular point to the derivative so that we can find the slope, okay? However, you know already, or we're given already the derivative because we're given the differential equation dy over dx. That means that is the derivative. So if we try to plug in your x n minus 1, y n minus 1 to that derivative, then we can say that the result of that should be equal to the slope we derived using algebra. So both are the same, but done in different ways. The first one in algebra, the second one in calculus. Now, since both are referring to the slope, we can equate them. And by doing algebraic manipulation, we can manipulate this and revise this so that we can have y sub n equal to this one. So this is actually just a modification, algebraic manipulation of this. Again, this one is the slope using algebra, and this one is the slope using calculus. The resulting equation is what we call as Euler's method to approximate the differential equation. The big question now is, how do we use Euler's method? All right. In Euler's method, f is a differential equation. X sub n minus 1, y sub n minus 1 is the values of the x and the y, and h is the size, step size, or the height. All right. Let's go back to the main problem. Okay. How do we use Euler's method to simply give an approximate value of the dE at x equal to 0.4? Okay. So first up, you have to know what your differential equation is, the f. Your differential equation is x plus 2y. Now, if we try to input these values to your differential equation, that means your x will be replaced by this. Your y will simply be replaced by this. Hence, this is now your dE. This is how your dE would look like once the input and the output has been plugged in. Also, it's mentioned that the step size is 0.1. So we could already begin at making a table. All right. So from here, we start with n equal to 0. All right. By the way, before we start with this, you can actually simplify this one by putting it in your Euler's method or formula. So you now have y sub n equal to y sub n minus 1 plus the value of h, which is 0.1, times the resulting dE. So this one is the resulting dE coming from this. So distributing 0.1 to both terms, we now got this. And since we have two similar terms, so we can just simplify it as 1.2 times y with a subscript of n minus 1. So this is now the equation we are going to use fit for this particular differential equation and given conditions. So again, we have to know our starting point. So here, our starting point is your x is 0, resulting to a y equal to 0. So before we started, meaning n is equal to 0, these are the values of your x and y. All right? Now, when we start already our exploration at n equal to 1, take note that the step up size is 0.1. So the interval here in the x should be 0.1 also. So 0, the next one should be 0.1. In the next n, the step up size is still 0.1, so this must be 0.2, and so on and so forth. Now we find the y. So how do we find the y? We just use this Euler's method, the one that we have derived previously. So here, to find your current y sub n, so that would be 1.2 times the previous y, which is 0. So this is, for this particular y sub n, this is your previous y, and this is your previous x. Meaning, the previous y is y sub n minus 1, and the previous x is x sub n minus 1. All right, so putting in the values, so y sub n minus 1 is 0, and the previous x is also 0. Therefore, if we simplify it, y sub n is equal to 0. Now, for the next y sub n, this is your previous y and this is your previous x, meaning y sub n minus 1, x sub n minus 1 relative to this when n equal to 2. So substituting it, you have this as 0, but then your x, the previous x, is 0.1. So computing it gives us a y sub n equal to 0.01. All right? Now, for the next x sub n, which is 0.3, so this now is our previous y and previous x. Putting it in the formula will give you this particular y sub n. All right? Now, can you continue on this? Pause this video and try to determine what will be the y sub n when your x sub n is equal to 0.4. Again, when you do that, this is your y sub n minus 1, the previous y, and this is your x sub n minus 1, the previous x. Pause this video and try to find the y sub n for this one. Okay? When you do that, this is what you get. Now, we stop on this only because we wanted to approximate your 0.4 x, and we wanted to know what the equivalent y value is. And we already have found it using Euler's method. All right? So here, when your x is 0.4, your y is 0.0684. So we can say, approximately, when x is 0.4, plug it into your function, it gives you an output of 0.0684. So this is now the approximation. All right? So this is the method. And if you try to look at this one, this is the graph that we had a while ago. Now, if we graph these values here, we could see that they're actually not exactly on the curve, but they are close to the curve. That is the reason why we're only approximating it. So if the question is simply approximate, you don't have to give the exact value, you can just give the approximated value, which in this case is equal to 0.0684. Okay? Now, question, is this method shorter, longer, or what, compared to the previous method? Basically, this is still long, very long. And during the IBDP exam, you need more time in order to answer the other items. That is why, for this one, your work only ends the moment you have the equation already. The rest will be done by means of calculator. So how do you do this by means of GDC? Again, in the IBDP exam, you have to show this portion here. You have to do this. You have to reach to this equation, fit for this DE. And then from here onwards, you can now use your calculator. So please take out your calculators and try to do this one at home, by yourselves. Okay? So how do you do this using your calculators? First up, you need to have the equation. And then after which, I'd like you to press mode. And when you press mode, you will see this. In this particular screen, I'd like you to click on sequence. So find function, instead of function, please highlight sequence. Now you would know that it's correct because the moment you click on Y, this is what will be shown. All right? So it is here that we put in the values. First, let's start with the minimum. So for the minimum, if you recall, we started with 0. N equal to 0. Right? That's the first n value that we have. So this n minimum is the first n value that we have. Usually it starts with 0. Now u of n refers to the x. This portion here, the x. All right? So, but this u sub n is not this one, but this u sub n or u of n refers to your function relative to the x. So this is actually the x sub n. Where do we get this from? Remember that the height is equal to the change in the x sub n, in the slope. If you could recall, if not, go back to the previous slides. So remember that when we got the slope, the change in the x will just simply be the height. So we can use this one and look for the function x sub n. So by means of algebraic manipulation, we can just say x sub n is equal to height plus x sub n minus 1. That is what we're going to plug it in here. However, instead of using x, we will be using u. Okay? So what you're going to do is to type it in here, and there are some notations that you need to follow. So here, x sub n is equal to h plus x sub n minus 1. H is 0.1. So it must be, instead of x, you use u. So how do you use u here? you have to press these buttons. So second and the number 7, that gives you the U. So once you have had the U already, close open parentheses, and then to get the N, you need to press this symbol. Okay, then minus 1, close parentheses, plus 0.1. This is now the function for your x sub n, which in this case we're using the U. All right, and then what is the value of your U when y is 0, meaning the first U? Based on the table, we had a value of 0. Go back to the table and look at the value of your x when your n was 0. Okay, next, let's now proceed to this one, the v sub n. So this one, you just leave it blank. V sub n refers to this. Again, you just have to type it in here since we already have it. So instead of y, you will be using v. That means second and then number 8. All right? So when you type it in, it should look like this, 1.2, and then the v, which replaces the y, close open parenthesis, n. For the n, again, press this one, minus 1, plus 0.1. Instead of x, you use u, close open parenthesis, n minus 1. All right? And then what is the value of v when your n is 0? Go back to the table. What is our y when n was 0? It was actually 0. Okay? Now, once you have put in all these values, just leave the others blank. And then what you're going to do next is to press second and then window, the table set. So when you click second and then table set, you will get this. Table start should be 0. Table should be equal to 1. All right? When everything is now set up, you now press second and then table, second and then graph, which gives you the access to the table. And when you do that, you will now get the table. Automatically, the table will be provided for you. Therefore, just look for a specific value of x that you're looking at, which in this case is 0.4. Okay, so this is now the value of y when your x is 0.4. It's 0.0684. If we compare it to the previous, it's the same. So using your calculator makes it easy for you. Again, before you do this, you have to make sure to be able to come up with an equation first, and the rest will be calculator. Pause this video, or you may go back to the previous time stamp for you to review on how to use it using your calculator. For now, let's have one last example. Okay, try to do this one in your seats, pause this video, and work it out on your own. All right. So remember, this is our DE, differential equation given, and then we have to evaluate our DE at x n minus 1, y n minus 1. So if we do that, we just have to replace the x with x n minus 1, y with y n minus 1. All right, and this is now our function, and our step size is still 0.1. So from here, we now try to derive our equation. So y sub n is equal to y sub n minus 1 plus h is 0.1, and for this, it will be replaced by this one. So we now have this, simplify it, okay? And since these are two different terms, we can factor out y n sub minus y n minus sub n minus 1 since they are common in both terms. Factoring it out, this gives us 1 plus the remaining factor. All right, and this is now our equation. Once we have the equation, we can now say using GDC. So this is where GDC begins. All right, by means of GDC, okay, so use the calculator, follow through with the method, okay. So for y sub n, instead of y, we use v, remember? So this is how it should look like in your GDC, okay. Use the appropriate buttons. And then v sub 0 is equal to 1, because here we say that we start with 1 for x, resulting to 1 for y. So this is when n is equal to 0, meaning n equal to 0, that's our starting point. So at the starting point, where n equal to 0, y is 1 and x is 1. That's why at v sub 0, y is 1. At v sub 0, rather, the value is 1. And then to solve for your x sub n is equal to x sub n minus 1 plus the step-up size. So it should look like this. All right. And of course, the starting value of the x when n is 0 is 1. Remember, this is the starting value. X is 1, y is 1. Once you have all those, put it in the calculator, the GDC. Automatically, you'll get this graph. Follow with the previous instructions. You'll get this table, and then from the table, look for the one that you're looking for, which is x at 2. So at x at 2, y is 3.8609. So we can say approximately y is equal to 3.8609 when x is 2. So this is only an approximation. This may not be the exact value. But since we're looking for the estimate, this is enough. And that's how you do Euler's method. All right? Again, what I'd like you to do now is try to do exercise 11N at home, numbers 1, 2, 3, so that when you come to class on Wednesday, we are just going to clarify on some parts, not everything that you find confusing. Thank you so much, everyone, and I expect you will do your part as well.